In this video, I want to broach a topic that I haven't seen much information about, and that can have a lot of gotchas that are very easily addressed when handling secrets in Prescient Designer or Node-RED configuration nodes in general, but any other node that has credentials, the topics and the things I'm going to cover also apply for. And so to motivate this, let's look at a very simplified stack of a node running on a RED. So we have the Prescient Designer or Node-RED runtime that is interacting through some interface with a node that has credentials. And again, typically these credentials are in configuration nodes, so that multiple other nodes can use the same credentials. And by credentials, I mean API, tokens, secrets of some sort, like passwords that are needed to access a particular service or any other piece of software that needs some sort of authentication. And of course, this node interacts with other nodes on the flow, and itself has a dependency stack that at the bottom can have an SDK for a particular service and any number of abstraction layers and libraries in between to make it easier for the node writer or node itself to implement its functionality. And all these arrows represent interfaces between the different layers of different software layers. And the issue is that all of these interfaces and boundaries between different pieces of software can leak secrets. And some care has to be taken to make sure that doesn't happen. And we'll see what are the most common ways to leak secrets and what can be done so that that doesn't happen. To motivate that, let's just look at a very simple example. We have here a connector node that has a configuration node, and itself has two credentials, two pieces of in the credential object, which is a host name and API key. The API key is defined as a password so that it's hidden from plain view when you're typing or when you review it. And here on the left, we see some the HTML piece of the node that defines this UI here on the right. And highlighted here is how do you define the credentials, both the host name and the API key of that password. And this is very well explained in the link here below. So that's the connector node, the one that's using a particular config node that has a secret. And we also have a sniffer node that essentially its UI is very simple, it just has name. And here you see the implementation on the left, which is pretty much boilerplate. And this is to represent any other node that's trying to, that we're going to use to see if we can sniff or get the credentials from either the connector or the configuration node. So these are this is setup, this is the UI definition, and the runtime of both nodes, at least on a simple-minded implementation is shown here. On the left here, we have the implementation of the configuration node. This is somewhat boilerplate, and we do a couple of things that are perhaps not advisable. One here is the credentials are, per the explanation of the link on the previous slide, it's in the credentials property of the node. So here we, perhaps for convenience, we just destructure it from node credentials and we store it in a node property directly. Then it uses the node object to get a client, this fictitious client from a service that needs that API token. And then it defines the node, and again, identical to the UI piece, it defines the credentials, both the hostname and the API key. And the connector is just a simple node that gets the configuration node from its own configuration essentially gets the ID from the secrets property, which is the input on the UI, and that just essentially echoes the message it receives. And the client that we have here as a mock client to represent some sort of SDK or abstraction library that uses the credentials, in this case, very simple-mindedly stores all credentials, and has only one method, which is a show method, that is meant to represent, to show in the console output that, hey, this is a client and that the credentials are accessible. And so on the sniffer node is a node that just looks for the configuration node based on its type. It doesn't know what ID it has. It doesn't need to, because we can use the red nodes, each node API to look for that node. If we know for a configuration node that we're trying to sniff, to get its ID. And then once we have the ID, we can again use, same as the connector node, we can use the red nodes get node API to get the node. And as an example here, we're looking at all the potential ways, or some of the ways that we can sniff the credentials. We are going to echo the configuration node in its entirety to the console. We're going to see if it has a credentials property with an API key subproperty. I'm going to see if the node itself has an API key property, and if as a client that uses that API key, if we can sniff the property from that client. And we're just going to see this. Once we get the client, we're going to also use the show method to see that the client has the properties, has the secrets itself that it can use. But all the ones above are ways to say, okay, can we, if we're a node that is not the configuration node or not a node from this package on the left, if we can still see the API keys. And this is key when you're writing nodes on a commercial scenario where you either getting paid for the node, or the node is being used by someone else that doesn't necessarily need to have access to the credentials. So if we deploy this node, you'll see that the configuration node has the API key in many different places. This credentials property is the one that's coming from the node write time, and it's there so that it's a way to communicate the credentials from that were entered on the UI. Because we destructure the API key and we store it directly in a node, this API key property is also there, and this is strictly due to the way that the configuration node was implemented. But also the client, which we may or may not have control over, also is leaking the credentials. So this is all sorts of horror and all sorts of things that you should not do. So the very simple fix for storing the credentials or the API key in the node property itself is just don't do it, right? Even if it's easier to deal with, less keystrokes to type, obviously not do it. And that takes care of at least one of the leaks. The next one is, once you get the client, which is the piece of software that actually needs the credentials, or any other piece of software that needs credentials, once all those clients or APIs have been called, just delete the credentials property from the node itself, because they're not needed anymore. Presumably all those other services or clients have been started, so they're not needed anymore. And that takes care of the second leak, right? So now the node itself doesn't have the credentials, and we're not really storing the credentials in the configuration node itself, which then leaves the client as, or in general, any abstraction layer below the configuration node as the source of potential leaks. And for that, I think it's good practice to destructure the credentials property, or in some way clone it or copy it, so that the objects or the information that we pass to clients or services that need secrets do not are not referencing the credentials node object so that we can later delete it, right? So just as a good practice to copy those. And then the key is that the client, you could actually use Node.js or JavaScript private class properties, which are defined by this hash before the name, to store those secrets. What does that do? It means that now you can see here on the client, it's not there, meaning when you just do a console.log, but it's also when you try to access it, it will give you an undefined. So as you see here, if we're trying to access it, it's undefined, but the client itself can still use it, right? So in this way, there are no leaks. So once the secrets pass to the configuration node, it is used to start any client that needs to use the secrets. And once that is done, it's deleted from the node. And then as long as the secret is handled properly by lower layers of the stack, then all is good. However, you always have to monitor that. As a real life situation that we found is the open source InfluxDB node, which has a configuration node to just essentially give you specify what database one wants to use, what it's a database, what's the URL, and what's the token to access that database. If you use the same sniffer node or similar to look at this configuration node, you see that there's 3 places where the credentials are exposed. One is the one I mentioned already, the configuration node. We know what to do about that, right? So when we start the connection with the database, we can, after that, we can delete that. So this is taken care of. But here, this client property, this is the InfluxDB SDK, Node.js SDK. And that is certainly not directly under one control. And the solution there, it's, well, what we did is contribute to the project and fix that. And the fix was essentially boils down to using private properties in the client class. And there were 2 spots where the token was being leaked. One was just on the options, this underscore options object. And this was interesting because it was being used just to start the transport layer, which is this other object, and then was not used again. So kind of same idea as explained before. Once this transport object in the SDK was started, then you could safely delete at least the token part of the underscore options property. And then for the transport itself, this transport object, that's a class, so we can use the private property of the class to store the token. And in that way, this SDK, at least in future releases, will not leak any token. So I hope this helps. It's an interesting topic, and it requires constant vigilance of all your supply chain, essentially, to make sure that the pieces of software that are under our control do not leak the token, but also all the dependencies that we're using do not leak the token. And if they do, if it's open source and you're willing, and capable to contribute fixes or fork it and try to fix this in some other way. Hope that helps. If this looked interesting, or if you have any comments, please let me know. Otherwise, till next month.